Today we are going to learn what is heap sort. So we can see min heap and max heap. Two kinds of heap are there, min heap and max heap. What is min heap? Let's see. Suppose we have this like 10, 25, 15, 30, 35, 40 and 45. Suppose where root is always minimum and childs are more than root, so this kind of heap is called minimum heap. Or here we can see, to find an element, here we need to do zero comparison because only one element is there, and here we need to do level wise. I am talking about one comparison, and here every time this and this we need to do two comparison like that. So to find first minimum, to find second minimum, to find third minimum, and so on. Find first minimum element, find second minimum element, find third minimum element, like that. So we can say, to find, suppose here this is this, to find first minimum, to find second minimum, to find third minimum. So if we need to find 10th minimum element, so how many comparisons are required? According to that, the number of level, third minimum, so because up to 10th level, so 10 and 10 minimum comparisons are required, but to reach up to 9th level we have to add all these. Up to 10th level 10 comparisons are required, but to reach up to 9th level we require 0 plus 1. This is first level, this is second level, then third level, like this. So we need to up to 9. So total we can say n plus 1 by 2, or we can say 9 into 10 by 2, that is 45 comparisons are required. So how we are going to store it, minimum heap? We can store like this: first root element, then its children, then 25 children, 30, 35, then 15 children, 40, 45, like this. 1, 2, 3, 4, 5, 6, 7. Like this we can store. Or we can say, in a given complete binary tree, at every node root is minimum comparing to its children at every node, then it is called min heap tree. Or we can say, order of n time to find min element in best and worst case. In both the cases we need order of n time to find minimum element in best and worst case. Or we can say, if we have total n number of elements in this, as we have seen in the number of comparison, according to number of comparison, if n elements are there in mini heap. So according to this as we have done here, n plus 1 by 2, so we can say order of n square. Time complexity or time taken in minimum heap. So in the next lecture we will learn how max heap will work.